Hello, everyone. Welcome to the DataFlint webinar. It's been a long time. We had the Databricks Summit to those who attended. It's been around 2 months since our last episode. And today I am with Jerry from Databricks. Super excited. We actually met in person first time. It was the summit. Was super cool. So before we start, before I introduce Jerry, a few words of housekeeping. Um, we are super excited to host the webinar. And for those who are attending first time, I'm Daniel, co-founder and CTO of DataFlint. Big fans of Spark, so I guess most of the webinars are around Spark. And what we do is actually help both with cost and performance of Spark. So I'll share a minute our website and feel free to visit it after the webinar. And let's see. Okay. I'm sharing the website, and at the end, how we help with Spark cost and performance, also on Databricks, is by leveraging what we have today with agents and LLMs. At the end, users could use their IDE wherever you write your Spark jobs. Also could be a notebook, let's say on Databricks. And then in Databricks, there's Genie. Actually, I think the last webinar we showed how DataFlint interacts also with Genie in order to help it understand the performance. And then at the end, it helps users to debug and optimize jobs. So again, this is our website. Feel free to check it out later. Actually, here it's our current webinar. Later this month, we have a Spark meetup in New York. So people in New York, well, I guess it's noon now in New York. Feel free to join. It will be hosted by Datadog. And we have great speakers. Somebody comes from, I think, Lake Sale to speak, which is cool. Also, someone from DataFlint. And also, we are going to be this end of the month in the Airflow Summit, although it's not Spark, but there are, of course, connections. So that's going to be cool. Feel free to check it out. And that's us and some housekeeping for the upcoming month. So I'll go back to Jerry. Super excited that you joined. You've been doing streaming since, I guess, the beginning. You worked at Splunk, Citadel, Yahoo, and you contributed to Pulsar, Storm, Heron, and of course, Spark. So thank you very much for joining, Jerry.
Yeah, thank you so much for having me, Daniel. I'm really excited to be here to, talk about all the cool things we're doing in Apache Spark and all the cool things we're doing at Databricks, on top of Apache Spark. So yeah, super excited to, talk about that.
And currently, you're a staff engineer, Databricks, and you work on those topics, right? Specifically real-time mode.
Yep. So my team is basically the what we internally call the stream engine team. So really anything that is related to structured streaming, right, is kind of goes through my team. Our team is basically responsible for maintaining, developing, supporting, structured streaming, both kind of as a product of Databricks, but also as an open source product
Yeah.
in the community as well. So we do all of these kind of things. So my team also actively participates in basically building open source structured streaming and Spark streaming as well.
Cool. So as I mentioned, you started long time ago at streaming. So tell us a little bit how did it happen? I think also like in your undergrad, right? You already started doing some distributed stuff. So feel free.
Yeah, great question, and it's actually quite a fun story to tell. So in my undergrad, I did start to dabble with distributed systems, right? That's kind of where I got interested, just using kind of commodity hardware. How can we do things that you can only do on supercomputers back in the day, right? I do I need to go get a supercomputer or can I just get a bunch of, my old laptops together and do something cool, right? So that's how I get started, got into research, then decided to go to grad school in Illinois. And the this is where I really got into kind of stream processing and distributed data stream processing is because of my advisor. The kind of funny story here is I was taking his class on distributed systems at Illinois. My advisor is Indranil Gupta. He's still a professor there. He actually, does teaches one of the large, like bigger MOOCs on distributed systems
Mm,
nowadays. So he was my advisor. I took his class. He was talking about things like Storm back in Apache Storm back
mm.
in the day, one of the, OG original kind of open source data stream processing systems if people still kind of remember back in the day. Came out of like, Backtype and Twitter, but it was open source. To be honest, when he was talking about it, I actually fell asleep during that class. I did not even remember what he said. And then I came to his office and he was like, Jerry, you should go do research. This is the hot area, stream processing. You should go do research on Apache Storm and stream processing. And
All
to be
right.
honest, initially I had no idea what he was talking about, but I was too embarrassed to admit it. So I was like, yeah, sure, let me look into it. So this is
Storm, it
kind of where
sounds
my journey
nice,
began. Sorry?
the name Storm sounds nice, for
Yeah,
sure.
exactly. It's like, oh, so exciting, right? It's a storm, like it must be cool. So that's where my journey began, is in kind of grad school in Illinois, and we did some research on Storm, and published some papers. Eventually, I went to kind of implement some of my research at Yahoo at that time, which they also had an office near kind of the campus. I worked there for a bit implementing my research, also just working on Apache Storm in general. Then there was a transition. I moved, to try out finance for a little bit in Citadel, but eventually,
Which years was it? When did you move to Citadel?
this was like 2016, 17 kind of
Okay.
time frame. Yeah, yeah, yeah. I still kind of worked on Spark at Citadel to some extent. But finance, I didn't think it was kind of my thing. My calling was still kind of stream processing. So I ended up joining a startup in Silicon Valley called Streamlio, with some folks from Twitter that I
Hmm.
actually knew from working on Storm because, Twitter was kind of the original place, if you will, where Storm and all of these technologies came. They acquired a startup called Backtype with Nathan Mars and all those folks that actually created Storm. But Twitter was a big kind of user of Storm initially because, a lot of their, especially ad platform, was built on top of Storm. So we joined a startup, worked on more things like Pulsar, Heron, basically streaming systems, PubSub and streaming systems. Got acquired by Splunk, worked on a variety of things there as well. Flink, Pulsar and whatnot. Even at Yahoo, to be honest, there was actually a famous kind of a benchmark that even people cite today called the Yahoo Streaming Benchmark, which basically compared, Spark streaming with Flink, with Storm back in the day. But to be honest, we were a little bit more trying to get Storm to win in a sense back in the day because Yahoo was a big Storm shop
Interesting.
back in the
I
day,
didn't
and
know
we
that.
actually talked a bunch of trash about structured streaming and somewhat to Flink, but maybe people didn't know. I actually wrote the Flink version of that benchmark. So, comes all I've kind of worked on all of these kind of systems and been around this whole community. But, after Splunk, I came to Databricks and started working on structured streaming, which, looking back is almost kind of ironic to some extent because back in the day, my thoughts on Spark is maybe still kind of what people think is like, oh, that's just like not real stream processing. That's just kind of, this and that, this is it's which kind of what I thought was back in the day because I really drank the Kool-Aid of, the kind of especially people working on Storm, working on Flink. But now I think I have a different perspective on things that I've
I love it because that's like if
yeah.
we can unpack exactly this claim and like your revelation and show it to the
Yeah.
audience, that would be great.
Yeah. Yeah.
I think that's actually dovetails to the next question. So we all, me included, I know how Spark works as a batch, right? So when we have lazy evaluation and actions and transformation, etc. So I have the mental model of how Spark work when I use it. Assuming I know that, how would you explain to me why it's not good enough and why do we need streaming and what it is exactly.
Yeah, sounds good. So just kind of taking a bird's eye view of, what batch is, what stream processing is, right? To be honest, in my head,
Mm-hmm.
there is not so much of a difference. And to be honest, for people that are not familiar with stream processing and you're doing batch processing, today, right, which is kind of the, simplest form to describe it is I have some data, I ran some sort of query, some sort of processing on it, produces some result, and then I choose maybe at some other time in the future, I get some more data, I
Yeah, an
process the
ETL,
data again.
classical
Exactly.
ETL.
Classic EDL stuff, right?
Yeah.
That's already stream processing, to be honest, right?
All right.
Because what stream processing is really processing an unbounded amount of data, right? Maybe people think of stream processing as, oh, it has to be like under 1 second or under some sort of, SLA, right? Sure, for some use cases. But in general, it really is just describing the effect of processing continuous amounts of data. And to be honest, for people that's where I come back to, like when people are doing batch processing or what they think is batch processing, they're already doing some sort of form of stream processing. They're basically having some sort of set of data. They're running some, application queries or, processing on that data, writing a result, and they're repeating that in some sort of time interval, right? Over and over again.
Yeah.
So in a sense, it maps to kind of that model of stream processing, which is, you're processing, new data, continuous set of data. It's just a matter of the latency or, what kind of, when you get the results, when you kind of materialize your results and so on and so forth, right? So in theory, when we talk about stream processing theory, batch processing is just a subset of, stream processing. It's a special case of stream processing in a sense because really, when we think about when the from an implementation wise, batch processing is that it's not stateful in a sense, but in a sense you're manually keeping some sort of state either in your head. That's like, okay, where's the last time I've left off? So I need to resume from the last time. Or maybe you are keeping it somewhere kind of persisted somewhere. But that's really kind of the practical difference in a lot of, say, batch processing systems and streaming processing system is the idea of tracking progress, right? But in practice, a lot of people are already that are executing these batch queries, batch applications. They're already doing stream processing to some extent. It's just maybe they're not kind of leveraging, kind of some of these built-in primitives stream processing engine would give you, like, state. So really, when we say stream processing, you can almost think about it as incremental processing as well, right? Batch processing, you can also think the other is like incremental processing, right? Instead of one giant batch of data, I might basically split it into multiple, batches of data and just kind of keep track of the progress, right? So stream processing in another way is I'm doing incremental processing. I'm keeping track of some sort of state, some progress and some internal state. But the output is that, whether I process one giant batch for 1 day's worth of data, or I process basically, what we say micro batches in this amount of time, the result should be the same. So from a high level, I would basically think about it, like, that stream processing and batch processing are the same, are, two sides of the same coin.
Okay. So my following question is, if that's the case, um, why do we have still this, dichotomy? Or I don't know, like two sides of the coin, right?
Yeah.
Is it from a like historical reasons because it started somewhere and it was mostly, what we say ETLs, and
Yeah.
nobody thought about, okay, that's how it should be done, or like, how would you answer that question?
Sounds good. So there are still some, I would say, use cases of batch processing, right? If you're doing some sort of data exploration, right? You're wanting to run some sort of point queries. Really, that's another distinction
Like
between
in
kind of standing
notebooks, let's
queries.
say on
Yeah, yeah. Like in a notebook and somewhere you want to do some data exploration. You want to run some point queries. Yeah, I mean, I still think there is some kind of benefit there. You don't want to have something continuously running, right? You want to do some maybe one-time data exploration. Yeah, there's definitely kind of a use case for that. But to be honest, if you say, you've run your query, right, and you've got the data, and you kind of want to now use that query, right, or pipeline to power some sort of dashboard or something like that, right? I would say this is a great time for you to convert to some sort of incrementally processing pipeline or a stream processing pipeline, like a materialized view. That's almost incrementally basically computed, and the results you would get would also the updates based off of new input, you would also be reflected in a quicker fashion. And materialized views, incremental processing, and stream processing, they're really almost they're different terms, right? Originated from kind of almost maybe different areas, but they all really mean the same thing is you're really looking at the new data coming in, and you're basically computing kind of the updates based off of those new data. What updates should I basically emit as output based off of these kind of new data, right? And that's one of the powers I think of incremental processing over batch processing is if you want to keep a dashboard up to date, right? And you're just using a batch query, you literally have to run your batch query and maybe scan all the data over and over again, data that you've already scanned before, right?
Yep.
Which is, a huge overhead in terms of cost and your time and, latency to getting fresh results. But if you basically to be more performant and more, cost effective is I've already processed all this data, maybe yesterday, sometime before. I just want to see kind of what this new data that came in and what its effects are on kind of my existing outputs, right? Let me just compute that difference, that diff,
Yep.
right? And apply that diff to my output. And that's what really kind of stream processing is at the end of the day. And it allows you, so it gives you two things. It basically gives you efficiency and cost efficiency and both performance efficiency to only process that, diff. And also, it gives you better reliability and fault tolerance. That's another thing. Because if you have a really large batch data,
Okay.
it takes a whole day to process, and it fails in between because a lot of these systems they don't have any state. Usually, you just have to restart it again, right? And
True.
maybe you get so unlucky that in the last second before it finishes, it crashes, and then you have to basically process all that data again. But because this is another benefit for incremental processing is that we typically will split larger data into smaller chunks and then checkpoint that progress. If you fail, it's not that the big of a deal. It's not as big of a deal if you can basically checkpoint your progress as you go along, right? So that's another benefit I would say of kind of incremental processing, stream processing over just the traditional batch processing paradigm.
But my question to you, okay,
Mhm. Yeah.
sounds reasonable as someone who does batch all the time. But I'm trying to
Yeah.
understand. Let's say I wanna do ranking or window function on my whole full data set.
Mhm.
Um, so how would that work when you have like an unbounded table, right? And the data is always updating.
Yeah. So if you want to basically say you have like a window function, right? Are you talking about kind of if you want to do some sort of aggregation on a tumbling window or a sliding window? That's kind of,
Yeah.
the use case, right? That's also supported in stream processing as well, right? Um, we have the kind of, so what I think one of the interesting ideas, and maybe this is one of the complex ideas that it's a little bit more difficult to understand is kind of completeness, right? What is kind of when should I emit results for data, right? Because before in batch, all my data is there,
Yeah,
right?
exactly. That's what I'm asking. If I want to do
Yes.
an operation that requires the whole
Yes.
data, right?
Yes. Yes. Because we assume in these batch workloads, all of the data is there, there's no chance of some late arriving data. To be honest, there still is. If you really think about the edge cases, there is. But generally people assume, okay, I have this batch, I have this chunk of data somewhere.
Yeah.
It's complete. All of the data is there. I process it. I don't have to worry about, and I just basically group by window, right? I don't have to worry about, oh, like when am I going to see some, result for this window? Maybe it's out of order and things like that. So one of the kind of big areas of stream processing is, how do we deal with kind of incomplete data, out of order data, right? Because data is coming in, right? In
Yeah.
streams, how do you kind of deal with these concepts and when should I emit a result, right? This is where basically we use the idea of event time and watermarks to
Mm.
basically give you a sense of completeness. And let me kind of describe those, concepts, right? So event time is basically the idea of when some sort of event, a row, piece of data got created, right? And you're trying to basically group, say you have a time window, right? And you're trying to say a time window, you want to group all these events, maybe count them, do some sort of aggregation, but you want to basically group these, events into based off of their event time, their creation time, into these distinct, time windows, right? Discrete time windows. But you know that, okay, some of my data, because it's coming from all these different sources, some of them can be delayed, some of them can be out of order. So when should I actually say between this time window of 10 a.m. to, 11 a.m., I actually have all the data and I can emit my kind of aggregate for that time
Yeah.
window, right? Because, data coming in at all, points in time, right? Versus in the batch case, I've already waited for a month or a day or whatever. All the data is there, right? I'm processing previous
Exactly.
day's data. It's already there, right? So this is where kind of you can, use a watermark. Basically, it lets you declare um, what is the, what is kind of the horizon or what is the kind of point up to what I am confident that any sort of previous event from that has kind of a lower event time has arrived. So basically, the idea is a watermark is telling you that no that date that a watermark is a time is basically another kind of a timestamp, but it kind of tells you that okay, like I expect no data older than this watermark to arrive. So one of the key
So
things
it's
and
my
one of the challenges,
tolerance, right,
exactly, it's a
for how
tolerance
late.
for late or delay of data.
Yeah.
Exactly your thing. And there's obviously some nuance into how you should, set this watermark, but typically a very kind of common strategy is some sort of delay on event time. That when I see the maximum event time across, kind of what I've observed, and then I subtract like basically X amount of time. So I basically what you're saying there is you are tolerating X amount of time of out of orderness. Say you can say 30 minutes, right? I expect 30 minutes of out of orderness of all my data, but after 30 minutes, I can say, okay, I'm pretty confident that all my data arrived, for basically this window. So for example, from 11 to 12 o'clock, right? If I have configured a watermark delay, is typically what we call it, of 30 minutes, that means that, when I see a water event time of 12:30, I basically have said, the engine will say, I've waited long enough. I can close this window and I can emit that result
Hmm.
of that aggregate between 11, to 12. So
Got it.
these are kind of the tools that, and there's a lot of nuance in how you're supposed to set the correct watermark, right? Because, there's always this, it's like, well, can always have more delay data, but it's really now it's a trade-off between kind of completeness and latency, right? How long would you want to wait for your data to be complete
Hmm.
and everything to be there versus how soon do you want to emit a result,
You want
right?
the
And then there's all of the nuances in between. It's like, okay, well, I want to basically emit, more frequently, but I want to get updates later, right? And there's, in Spark, we have things called like update mode versus append mode. Do you want to just get one final result, or would you want to get more incremental updates so that you can just say, okay, based off of input, I get an update. It might not be complete, but at least I get some sort of result, at least the current kind of view of things. And eventually it would be still, the right, data, right? So there's all these kind of, ways you can say when to materialize my result.
Yeah.
How often do I want to output and things like that. But usually the idea is using event time and watermark to basically give you allow you to do some trade-offs between completeness and latency.
Got it. So cool, you convinced me that it's something I should look into it.
Yeah.
So my question is practitioner. So I have now a lot of I Spark jobs running. What should I change first mentally about my thinking if I wanna start thinking about them and as streaming, and also practically is let's for now assume we're using um, regular Spark. We're not doing declarative pipelines or anything like that, like
Mhm.
classical stuff, what most people are doing. So first, what should I change in my mental model? How I should start thinking, and what practically how it's going to affect what I'm doing in my code or whatever on configurations. Okay, in high level, we shouldn't go like into all
Yeah,
the
yeah,
things,
yeah.
just something as we should be thinking about as practitioners.
Yeah. I think let me kind of read back your question to make sure I understand fully. So your question is like, okay, as a practitioner of say Spark, I use a lot of batch queries as it is, right?
Yeah,
Is there some, should I start thinking about some of these applications or queries in a different way, right?
because I
Should I
want to
convert?
improve performance or cost or
Yeah,
something, right?
yeah, yeah. So I think a very good sign, that or signal that you can look at
Mhm.
is, are you periodically running, just like my previous example, right? Are you scheduling is some batch query to run periodically
Yeah.
at some point, right? That's a very good signal. Say for example, I know a lot of people have this. They have some files in S3, right? And some bucket, right? They just have a cron job that just like does it every single day to process the previous day's data, right? Like because they know, okay, at this point, I've all my data has come in for the previous day, I can process it, right? I schedule a cron job, I process the previous day's data,
Or they
and
do
then I dump
compaction
it.
or
Sorry?
whatever. Compaction, right? I do it every day or something.
Sure, sure. It can be, you can be doing some sort of compaction
Yeah.
of your data. It could just be like, okay, I have staged the data for the previous day in each and kind of in each prefix, right? Okay, for t today's data, it's in one prefix, tomorrow's data is another prefix, and I just keep basically fetching the data over and over again. Right. That's one way to organize. That's a very smart way to organize it. But a lot of times it's I just have a bunch of data in one bucket somewhere, right? And I basically would reprocess the data over and over again, maybe with some different data and things like that, right? But at the end of the day, it's really about, I think if you have a schedule that you're running some sort of batch job, that's
Yeah.
where you can basically think about, is this basically an opportunity for me to use a streaming job, a streaming pipeline to basically do that for you, right? One is, maybe for efficiency, right? Like because a streaming job in structured streaming, it keeps track of, say, what inputs I've already consumed and what are the new inputs I need to consume.
Yeah.
And basically, you don't have to reprocess the data that you've already processed, right? So these are kind of the patterns. If you basically are doing something on a loop, on a schedule, think about if basically you can leverage stream processing for those cases and help you, I would say, simplify your tech stack because a lot of these things about keeping progress and things like that are built in to the stream engine. And things like managing state are built into the stream engine. And sometimes those are actually quite difficult things to get right. The most difficult applications to write are stateful applications, I would say. And, the stream engine should be there to basically handle your state for you. So you don't have to basically debug and figure out, the semantics of when there's failures and things like that, where to recover from. All of that should be handled by your stream engine. So really kind of these applications where it's running on a schedule, reading some sort of data that you have, maybe you get updates on it. Think about if you can maybe move it to an incremental or stream processing model.
Got it. Thank you. That is
Yeah.
super useful to practitioners. And my next question would be, okay, so s streaming in Spark, um, as far as I know, it's like the micro batches,
Mhm.
right? So what's happening recently? So let's get to, let's say, more to the present of what we have and maybe how real-time mode gets into play here. Explain like the difference. Is it's not structured streaming? Like again, I'm
Yeah.
curious.
Sounds good. So, to kind of let me maybe kind of give a high level overview of how structured streaming kind of works, right? In terms of how it relates to, batch processing in Spark. So, batch processing, you can imagine in Spark is you have one batch that consists of maybe many stages depending on type of your query. Stages consist of tasks, they execute in a cluster, they return kind of a result to you, right?
Mm-hmm.
Um, we basically, leverage that idea. It's like, well, how do we do stream processing with that, right? Now, batch processing, it's like, okay, I'm processing one distinct range of data or set of data, right?
Mm-hmm.
You can think about from file A to file B, right? Something you have a bunch of files, you want to process that, right? So now the thing is, well, how do I basically process an endless maybe number of files that are, being generated, right? So the very kind of easy and intuitive kind of mapping is, okay, we'll just have endless number of batches to process basically the new data. And we call them, this concept of micro batches. So it's exactly kind of almost what people are doing today. That's why I'm saying like, the very easy, way to say see if you have any sort of stream processing use cases is are you just basically running these batch jobs over and over again, right? Because stream
Yeah.
processing, structured streaming maps almost, basically directly to that idea. It's like, okay, now we have a continuous, a set of batches that are processing kind of new data as they come in, right? So the first batch processes one range of data. The next batch will process the next range of data and the new data that's come in. So that's really at a high level how structured streaming works. And there's actually, what's really cool about structured streaming, and I think this is where a lot of people don't maybe are not kind of aware is
Mhm.
maybe people think about stream processing as, oh, I must do it immediately, right? Or have some sort of very low latency.
Yeah,
But
like
really,
real.
it's not. Yeah, exactly. There definitely is. And we can talk about real-time mode, and I'm super excited about that. But a lot of use cases, it is literally people want to do this every once a day, right? Their SLA, their latency target is once a day. So in structured streaming, we have something called, trigger available now. It basically allows you to trigger your incremental processing at an interval of whatever you're choosing. So you can literally say, I want to start a structured streaming query and trigger available now, and I will trigger when I should basically do kind of the processing. Maybe it's once every single, day. What it would do is basically it would look at kind of what the new data what is the new data has accumulated since the last time I've run,
Mhm. So it's
process all of it.
incremental.
Yes, store any of the state or basically progress, and then shut down. And then you can decide when is the next time you want to run it. So it really gives you, at the end of the day, it really gives you kind of the flexibility to really decide, what to really trade off between kind of what your latency SLAs are and your cost, right? Because you don't need something that's continuously running. Maybe people think about stream processing as, oh, I need something that's continuously running to basically
All of
process
it.
data. Yeah, but it's not necessarily true. One of the biggest use cases of structured streaming, especially for ETL, is trigger available now. I just want to run every hour, every day, every, week, I guess. Like, just want to process all the data in the previous whatever week, day, hour, and then I'll shut down, don't incur any cost, and then I'll just do it again, right? Instead of doing that in a batch form where you have to keep track of
Perfect.
all the state, just do it in structured streaming using trigger available now. A very basically simple kind of an intuitive, map over of that, right? So that's one basically area of usage pattern of basically structure streaming. Another is where you get more into kind of the continuous processing realm, right? We have something called processing time trigger. And literally, it's basically running kind of these micro batches back to back, right? Processing this amount of this data, and then it's gonna immediately look for new data and trying to process it, right? This is where you basically have, tighter SLA kind of, you want lower latency, right? You just want to do
When you say
continuous
lower,
processing.
well, what's like your rule of thumb for
Sure.
lower?
So, say if you want to have, say, hours, your latency is in the hours, right? Use trigger available now. If you want your latency to be in the minutes and into, the maybe tens of seconds,
Hmm.
use, processing time trigger. And then we can, now we have real time mode, which is another basically mode for structured streaming that can now get into basically the millisecond range, right? So this is how basically structured streaming is able to kind of cover all of the various kind of latency buckets, if you will, or use cases with all the different execution modes. So users can really kind of trade off between latency and cost, right? It gives you these things. But that's the thing with processing time trigger, you're able to do kind of the continuous micro batch processing. And then now, what is more recent is real-time mode that Databricks that I've personally worked on in the last couple of years is to now basically attack those operational workloads that are in basically, the millisecond range, right? Where you require like P99 latencies, consistent latency in the milliseconds, right? We're talking about operational workloads like, in terms of a lot of common cases is fraud detection and things like that, right? Where you do need the time to detection or the time to some sort of event is very important. And if you miss that, you're losing money and there's an opportunity cost, right? So in the kind of the in processing time trigger and kind of in trigger available now, those execution modes, we're more focused on kind of almost throughput at that point, right? Not necessarily bringing down latency to the lowest possible, but we're most focused on kind of throughput and processing, a lot of data with efficiency. And then we basically move down the latency spectrum to real-time mode, and we can basically process data with millisecond latency. And the beauty of all this is it is really on one engine. We've recently open sourced real-time mode, so anyone can go to open source and take a look. Because a lot of time, talking from kind of a historical lens, is
Yeah.
people claim to have like, oh, these at least these APIs, right? That unify batch and streaming, and you can use one API to basically, express applications in both realms. But
So
really
that's
underneath,
structured streaming, right? So I think it was Spark 2, 2.0, right? When we
yes, yes.
had
When
the
structured streaming, it was Spark streaming on RDDs. And
RDD.
then we became we there was another evolution. Now things are on the data frame API,
Yeah.
right? Now it's typed. It's still on the data frame. That's still thing, but now we added a different execution mode,
So
right? We
just a
added
second, Jerry. I want to
sure.
remind the audience, if you have questions, feel free to write them. And then at the end, we're gonna address them. So feel free, specifically because we're gonna talk now more also about the future and everything. Usually that brings up a lot of questions. Yeah, continue.
Yep.
Sorry, I just wanted
Yeah,
to
yep.
remind the
Yep.
audience.
So I was saying, the data frame API, and now we have kind of real-time mode still on the data frame API, still the same API, but really kind of the difference between what I've seen in the past is this is still really the same engine. It uses the same Spark infrastructure, but to run queries at low latency. Because in the past, yeah, things from Twitter like Hummingbird, where it's one language, but I basically compiled that one API, but I compiled it down to a Hadoop job, or I compiled it down to basically a Spark job, depending on kind of your latency requirements. But it's really, at the end of the day, two kind of disparate and very different engines underneath, right? And that creates a lot of, unless you are, Twitter and you have basically 100 engineers to throw at the problem, like it's very difficult to manage this very disparate infrastructure. You have to manage Hadoop, you have to manage Storm, and things like that. I can talk a little bit more about that, but that's really kind of one of the selling points of even structured streaming today, especially with real-time mode, is people see it's like, wow, this is super awesome. This is actually the same engine, the same infrastructure. I run Spark, and then I can run basically batch queries I can run, what we say micro batch queries, and then I can run real-time mode queries all on the same kind of infrastructure. And I just need one team to basically maintain all of it. And it's a huge, basically, reduction of operational cost for the user. So this whole platform consolidation story, it really resonates with a lot of people that are using different platforms. Some, I have this use case using Spark. I have another use case using another platform, let's say Flink. But now, there's really basically, structure streaming with real-time mode can now make a lot of consolidations for especially the infra team for a lot of companies, and that's what we see. But to kind of come back to kind of
Yeah,
describe,
come back to why
yeah,
do we need, let's say, real-time mode in the first place? Like,
yeah,
what was the floor prior? What
yes,
was
yes.
the place we
Let
couldn't go
me
below?
exactly. So I talked about trigger available now, right? And we talked about kind of that's for, if you have tens of minutes, hours of latency, you can use trigger available now. You can run it, shut down your cluster, and then decide it to run at some later point in time, right? And then you have more continuous processing with processing time trigger, right? And that was kind of the lowest latency structure streaming could achieve for a while was with kind of processing time. What that means is just executing micro batches back to back. We're just
So
executing
what
micro.
was it in
So
like
we could,
minutes?
depending on the use case, right? But I would say it's in the kind of seconds, if not minute range, depending on the use case, right? We
Oh,
could not really get to the consistent under 1 millisecond range that, a lot of these operational use cases could get to. So this is enter and we saw like people are what were people doing at that time, right? People were using basically Spark and structure streaming to do their ETL workloads because ETL workloads typically do not require such low latency. And then they were using things like Flink to do their
yeah.
like, under 1 second, millisecond like processing, right? So you would have basically, the infra team, having to, basically support their Spark infrastructure, and then you have some team that, basically had to, run their back in the day was Storm, right? But then, basically Flink kind of took over that area, so it'd be Flink, right? And you have basically these problems, like I mentioned before. You have to support basically two distinct and disparate and widely different kind of how you would operate these kind of platforms. And one team would basically you would have to allocate resources and people to basically work on that, right? Looking into the future and kind of what talking to customers and talking to users of Spark, what resonates with them, especially with real-time mode is I don't need another engine anymore. I can just do all of this on Spark. With real-time mode and things like that, I can get those consistent millisecond latencies on the P99. I can just basically do everything on Spark. And also it helps the developer because a lot of times you have an infra team and then you have which basically serves internal customers that write applications on top of
Yep.
basically, that team, right? Oh, for this application, I have to know how to use the Spark API. Oh, for that application, I have to know how to use the Flink API. It's like, mental overload, right? Now doesn't matter, right? Just use the data frame Spark API and you're good to go, right? If you master that, you're basically good to go. One less thing for kind of the end user to think about, especially when what they really want to do is just implement their business logic,
Yeah,
right?
they
They
want
want to implement their
the
business
least
logic.
friction they can get, right?
Exactly. It gives friction to the users, it gives the friction to the maintainers, right? So, when we tell the story, especially to customers of Databricks, like and they're using Spark and they're using Flink, it's like you can consolidate. They're like, no-brainer decision to me. Like, let's do it, right? Like, and it really that really resonates to them. And that's kind of what RTM is for to serve those kind of business critical operational use cases that it was very difficult to implement. On the existing what we call micro batch mode, which is everything that's not real-time mode, is micro batch mode. And actually, some interesting kind of anecdotal things is we've seen some users actually just over provision there's because they actually didn't want to run Flink because that was too much of an overhead. So they actually over provisioned their existing structure streaming job using processing time trigger, and they were just trying to get it to run as fast as they can, right? And they actually, when they moved over to real-time mode, they actually
Mhm.
saved money because real-time mode, I'll kind of describe how it works. If you're really
Yep.
wanting those low latency kind of targets, like it's going to be much more efficient than just trying to give the existing micro batch execution mode like more resources and trying to basically get down the latency there. So that was also a very interesting revelation to us. It's like, oh, they actually saved money basically, and they got lower latency. So it's just almost a net win for them, right? They didn't even have to spend more money to get lower latency. They actually saved more money and they also got lower latency. So that was a very interesting thing. But maybe I can talk about kind of how real-time mode, works
Yeah,
and what
so
we
you said
actually.
we couldn't back in the day go
Yeah.
below, let's say, a minute, or depends on
Mhm.
the use case, tens of
Yep.
seconds. I
Yep.
do remember there was something experimental, continuous processing at
Yes.
some point, right? So is
Yes.
it the same idea that became real-time mode or no? Again, I really don't know. I don't have the answer, so I'm
Great,
talking to the
great,
expert.
great, great question. I get this question a lot. So the context here for folks that don't know this is in maybe 2017, 18, somewhere around there, there was an experimental mode released in open source Spark called continuous mode. Um, and it basically was it has similar ideas. It was trying to do kind of execute data using long-running processes on Spark, right? Which is kind of a similar kind of concept that real-time mode also leverages as well. But really, that effort was not fully baked in a sense. It was in a time where it was unclear whether there were that many kind of useful like use cases
Oh
at
yeah.
that low latency, and it only supported it was only at that point designed and it only supported stateless queries. So no state, so you can't do any sort of group by aggregation or anything like that.
Mm,
And it was only a single stage. So no shuffles,
no shuffle. Okay.
no shuffles, anything like that,
Okay.
right? And really, it wasn't, the design for how to support stateful queries. There were some ideas, but it never basically panned out, right? So it really kind of stopped, and it was only ever labeled experimental, and we never really supported it, even in Databricks. We never tell people to actually kind of use it, though. I have some anecdotal stories of people being, brave and actually using it in production. And when we told them about real-time mode, they were like, "Yay!" Like now I don't have to kind of do this myself. But really, kind of the difference here, in terms of just effort, right, is for real-time mode that we're truly, at least, from, Databricks, right, is we're truly kind of behind real-time mode and we're truly determined to build out real-time mode. So real-time mode does not only support stateless queries, it supports stateful queries as well, fully featured, right? There's of course some, things that we haven't fully supported yet, but the goal is to be so everything you can do in batch structure streaming, you can do basically in real-time mode as well. Obviously, like I mentioned, it's going to be an incremental progress, and we've already supported kind of at least most of the important things that you need to support for, especially operational workloads. But the thing is, we're fully committed, like to basically support this end to end for both stateless and stateful. And the other thing is what we noticed is, like I mentioned before, building some sort of application engine, mostly the most difficult and tricky part is managing state, right? All the different edge cases that you can have, of managing state and making sure, you recover correctly, making sure that failures are handled correctly. Very difficult to do, right? Of course, we can go down the direction of maybe say, you can argue, say, we can just work on continuous mode and you maybe add this, stateful support. Not impossible, definitely something, that can be done. Maybe it'll resemble more kind of how Flink does things. But what we kind of realize is it's a big operational risk because that means that we will have to kind of maybe re-implement a lot of these things that are very difficult to get right. Because structured streaming, stateful structured streaming queries, they've been running in production for, over a decade now, right? It's been battle tested for this long. We fixed numerous bugs, right?
Yeah.
Let's leverage that. Let's leverage that basically battle hardened code base as an advantage for real-time mode, right? Let's reuse the battle hardened code to also power stateful queries for real-time mode, right? Let's not write it from scratch because if we write it from scratch, we're going to make the same mistakes and there's going to be the same bugs and it's not going to be as good of a user experience as basically using all of this well-tested battle hardened code, right? So that's another basically thing I that we decided it's like let's try to leverage as much of the battle-hardened kind of implementations as code base as possible in structured streaming, right? So what we really did for real-time mode is
Yeah.
we do understand that a lot of times why we can't really get to the low millisecond kind of latencies is because we're not running batches for long enough. All of this kind of checkpointing between batches, especially if you have really small batches, that overhead kind of adds up, and you really kind of hit a floor on what you can achieve latency-wise. So what we decided to do is really kind of change how micro batches are planned, because before we're really saying one micro batch is responsible for processing this range of data, right? And
Mm-hmm.
then basically afterwards, we're going to see what is the new data, and there's another range. There's actually a lot of good properties of that in terms of doing exactly once kind of delivery and doing idempotent writes. Very, very, very good properties in terms of that, and it works very well for ETL workloads. But it really kind of is for these operational workloads. That's where it struggles at. So one of the things we changed is we still kind of have the idea of micro batches, but now what we're saying is instead of processing a distinct data range, we're going to execute it for a fixed amount of time. So we've really transformed in real-time mode this idea of a micro batch and checkpointing kind of the progress every kind of data range to almost the idea, we've evolved it to the idea of a checkpoint interval, basically. We're going to run each micro batch for, let's say, 5 minutes, and then we're going to checkpoint. And during that time, we're going to continuously pull for new data. We're gonna execute that, and we're going to emit the result immediately. So the other thing in order to make this happen is we had to rewrite the shuffle implementation as well, because currently in Spark in batch and also in structured streaming is the shuffle is blocking. In a sense, is one stage executes, it writes basically its shuffle files either to memory and also spill to disk, and then
Yeah.
the next stage basically processes. It's stage to stage. But obviously there's latency kind of issues in regards to that. So now we've built kind of an incremental shuffle. We call it the streaming shuffle. So once, say, a map stage, right, upstream stage, finish processing the data, it will send the data basically from a point to point immediately downstream to the next stage to process the data, right? So everything is kind of streamlined in a sense.
So
Once,
I'm trying to understand.
yep.
So um, I have two stages again, let's say
Mhm.
regularly. Now you're saying data is gonna move between them, not at the end of the first stage, right? It's gonna be all over the place.
Exactly.
I
It's going
mean,
to be
all the
pipelined.
time. I don't know if it's all over the place is the right
It,
word.
it, it's going to be yes, it's going to be well, I would use immediate. So once you're done with one record, you send it downstream to be processed by the next stage, right?
But on the task level, you mean, right? So,
Yes. Yes. Because you can think about, well, a stage is a set of tasks, right? That's the parallelism of that stage. Those tasks basically will shuffle data, right, to different shuffle partitions, right? It's usually using either range partitioning or hash partitioning.
yep.
This record will go to basically this partition, right? And that partition, outside of real-time mode and batch and kind of non-RTM structure streaming, will basically go to a shuffle file that's block by block that's stored in block storage, but also will spill to disk. And then once that stage, that first stage, that shuffle map stage is what we call it, is done, right? We have all of these shuffle files in already stored. Then the next stage runs and it consumes those shuffle files, right? So you run one stage at a time. And this new execution mode, right, is now we have mappers and reducers, the simplest model, right? Obviously, it can be, mapper, reducer. It can be many, many, many chains, but the simplest map reduce models, you have your mappers and your reducers. They run concurrently. And once the mapper is done processing data, a row of data, it sends it immediately downstream to be processed. So everything is kind of streamlined and you get basically output results much quicker this way. So to summarize RTM at a high level, what we're doing we basically evolved micro batches or micro batch type of checkpointing into basically checkpoint intervals. Now micro batches basically execute for a fixed amount of time and then we checkpoint. And then the other thing is now we run all of the stages within your query concurrently,
Yep.
connected by incremental shuffle we call the streaming shuffle. So all of this together basically allows us to streamline the processing of data and output results that can give you latencies and P99 latencies in the milliseconds.
Amazing. So we have a few minutes. I want to talk about the future before
Sounds
a
good.
few questions as well. So where you see streaming in real-time mode heading, and you have some internal knowledge, probably we don't, but again, as this stuff you
Yeah.
can share with everyone, that would be
Yeah.
awesome.
Sure. Of course. So one thing, just kind of heading into the future, right, is I see the platform consolidation story continue to basically play out, right? As in, users don't want to manage so many different things, right? Especially disparate things, right? They want
Yep.
to consolidate on one API, one infrastructure, be able to support all of kind of their data queries, right? Data applications, right? So that's something, we see really resonate with folks, and that's something that we keep basically improving on at Databricks is you have one basically platform that fulfills all of your data needs, right? From your batch queries, from your data exploration queries, right? Or your data warehousing needs, right? All the way to your ETL, and then all the way to basically your, operational workloads, right? You're able to use one API to basically do, all of this and run
Yep.
on a single kind of infrastructure, right? The other thing I would say is something that I think we're gonna, work towards is you still have it's still kind of imperative in a sense, like, oh, you have the idea of, trigger available now that's used for this kind of latency ranges. You have processing time you may use for that kind of latency range. And you have real-time mode you can use for basically, even lower latency ranges, right? And users have to kind of still have that mental mapping of which execution mode to use for what. I would
Mm-hmm.
say a better way is to abstract all of that at a higher level, right? Is to say, okay, I have some sort of freshness target, either on some sort of table or some sort of latency target. Select which one I should use for me, right?
Yep.
And it's usually not so clear cut because based off of the type of query, type of workload, oh, it might be borderline between trigger available now and processing time or processing time in real-time mode. You can have these kind of feedback loops to say, okay, maybe, sometime, I can automatically switch between these triggers based off of what I'm trying to optimize for, right? If I really want to hit this latency, and I need real-time mode, I'll run real-time mode. But if I increase the latency, I automatically switch to another kind of execution mode, right? That automatically kind of, picks the best, most cost-efficient execution mode that meets your SLA, right? I think that's something that would also greatly kind of improve the, performance so people don't even necessarily need to know about real-time mode, trigger available now, all these different execution modes. It's all kind of abstracted away from the, it becomes more declarative, right? I think the direction, a lot of where is making things simple and making things declarative, right? Don't have to think about a lot of these kind of externals about how to execute. It's more just like, what do I want to compute, right? This is
Yep.
what I want to compute. You figure out what is the most efficient way to compute it, right?
Amazing. And we have exactly 2 minutes, so we're gonna do quick questions.
Yeah.
Ganesh is asking, since streaming stages are running concurrently and non-blocking, can we set parallelism independently per stage or operator in real-time mode?
Yes, yes. I mean, you can already do that in the non-real-time mode, and trigger available now and processing time. You can already do that, but yeah, you can also basically fine-tune the parallelism of each stage in real-time mode, as well.
Cool. And Sonu is asking, how do we handle data skewness if we're using streaming?
So data skewness is there's many ways to solve it, but it's, to be honest, not a unique
Yeah,
stream processing problem, to be honest. You can also have
exactly.
that in your batch query as well. It's like, okay, in the most straw man case, like what if I basically, I'm grouping on a key and the key has a cardinality of one, right? And everything just has to go to one task, right? That's the worst case scenario, right?
But I'm curious, is streaming has extra difficulties if you have skewness in data, or no, it's the same. Like, does it add any problems that we won't get in batch if my data is skewed?
No, to be honest, I don't think this is a
Oh,
unique problem
okay.
for streaming. I mean, there's different techniques you can maybe like do instead of do you can try to do range partitioning and things like that, or you can try. Generally speaking, it's not usually the work.
Or
You have one
salting or
key,
whatever,
right?
right?
You can there's things like AQE, right? That happens, which basically tries to dynamically either coalesce or split basically your shuffle partitions based off of size. But in the worst case scenario, if you actually have a cardinality of one that's your basically grouping key, then you kind of need to figure out what is there another grouping key I can basically use, right? And
Yes.
that's not a specific problem for I would say streaming versus
Yeah.
traditional batch queries.
Perfect. So our time is up. It was a pleasure. I felt like we could have continued this talk for much
Yeah.
longer, and I tried to squeeze in stuff at the end. Again, thank you very much, Jerry. It was a pleasure, and for sure, I learned a lot.
Yeah, thank you, Daniel, for having me. And I would encourage everyone kind of listening here, go try out, structure streaming, real-time mode. It's in open source, participate in the community. I'll be glad to, talk more with folks, on the forums and in the Spark community, open source Spark community. So, please, please get involved.
Yeah, for sure. Big fans of open source, and if it works, tell me. If it doesn't, talk to Jerry.
For sure, for
He will
sure.
make it better. Okay, cool. So thank you very much again, and thank you to everyone that joined. And I'm gonna see you next time.
Sounds good. See ya.
Bye.